Okay, everybody have a chance to look over these. I had a particular question from this, and Dylan was correcting me, and I'm not sure. Um, anybody have any issues with this before I open my mouth?
With what?
Did anybody have any issues with the minutes at all? Did they see anything here that needs to be addressed? Okay, so my concern was with element 4, okay? In the drawings that Dylan sent out, it shows the screws going into the tread in the same line as a screw going into the riser and into the stringer. And my thought was that we had said that that screw would be 3/4 inch from the edge, the ones into the tread. Am I incorrect? Is the drawing correct? So both screws in element 4, the corner post, are going to be in line. One goes into the tread and one goes into the riser. On the other face, one goes into the tread and one goes into the stringer.
I think the drawing is correct. I remember I think it was Ashley was saying that the if we put it if we move them towards the edge of the newel, they'll likely end up in the glue line between the glue block and the
No, the screw that goes into the tread,
yep.
going into the glue block.
And I think the installer would likely make it in line with the other one for visual purposes.
Okay, my thought was that the heck with visual, and that the closer to the edge that we can get with that screw without it splitting and going into the tread, is it gives us a little bit more leverage. Not unlike a base plate on a post that's 5 inches instead of 4 inches. If you know what
Yeah.
that's, based on that principle, that's why the angle that goes around the base of the post, that's why those what do you call those L brackets, those are stronger than the bolt in the center because they're further out.
Right. So we could move the upper screws if
Well, I don't want to do it if everybody's okay with the one. That was what I thought we had. But what do you want to do? Keep them in line?
This is the audience participation part of the program.
Yeah.
Yeah, I mean, we're talking about only moving it 1/2 inch because right now I don't think it really will make much of a difference.
Well, the tread, if it has a return on it, okay, then the screw that goes into the tread is only looks like 1/2 inch away from the end of the tread. Okay, so
But with a 1/2 inch radius on a 1 inch tread, there isn't a lot of meat around that screw.
Nope.
So should we move it so that move the upper screws closer to the edge?
I mean, there may not be a problem with this screw, okay, because you've got 1.5 inches of nosing. Okay, this is the leading edge of the tread. Here's your stringer. All you have beyond this point is air. because this is a return nosing. Now the screw is only, half an inch in from the end of the tread.
Oh, I see. Okay. I didn't see the red line.
So, yeah, the red line is the post. The post is out here. So my thought is we move this in so that it's basically gonna be right at the edge of the stringer. But in the tread. So it's gonna be an inch in from the end of the tread.
So it would be, the center of the hole would be 3/4 from the edge of the
3/4
post.
inch in from the edge of the post.
Okay,
So both screws. Are we okay with that? All right, I'm seeing heads nod, so I'll go with that. Okay, so now, the other thing that, before we get on to, any other questions with this? That we've done so far? Okay, now what we need to decide, I know there was one comment that we attached the riser to the tread with pocket screws and glue blocks, but that doesn't show up in the minutes, and it was just a brief comment. Is that agreeable?
Yes.
we don't use pocket screws at Hardwood. We just use a solid glue block and staples. And I'm not sure is the pocket screws definitely the standard?
I don't know if it's the standard. I know that's what we do.
We
I
use
know
pocket
Bob.
screws also.
Yep, Bob uses pocket screws. Maybe I need to convince Bill to start using pocket screws.
Well, it would suit this, and the good thing about a pocket screw is, well, it's quite strong. It pulls the tread down
Mm-hmm.
onto
Yep.
the riser, okay? And it leaves a flush surface, provided you don't have a lot of burrs there. But you can put glue blocks in between the pocket screws. If there is a burr there, or you can run a glue block all the way across, I guess, if you wanted. So that's the next question. If we use a pocket screw, are we going to use a glue block?
It's right, wrong, or indifferent. It's just what we do. We use glue blocks and the pocket screws.
Yeah, I think the glue block is important.
Okay, and how long are your glue blocks?
Whatever we decide to cut them to.
Okay.
I think ours are approximately 4-inch sections, 5-inch sections.
And Paul, you use the do you guys use triangular glue blocks that you just like?
Yeah, because we like the way they staple in better.
Yep. Instead of, because we're using like a square, just
Yeah.
the same 1x1 square.
Yeah, and I would be surprised if structurally if it mattered. We just when we staple it, we find it's easier to make sure we've got it right.
Mm-hmm.
And are we using 1.5-inch staple? The narrow crown? Or shorter?
I honestly don't know. I could check.
Probably 1.25 inch. Well, how big is the triangle that you guys use? Is it like a cut from a 2x2? 1.5 by 1?
It's actually all fall from a yellow pine tread, so it's basically inch by inch.
Inch by inch cut on a 45, so you get two of them.
Yeah.
Yep.
Gotta be using a much shorter staple then.
Mm-hmm. They're probably 1-inch staples.
But your glue surface area stays the same, whether it's
Yeah.
square or whether it's triangular.
Yeah.
All right, we're gonna use a 1-inch staple and a 1-inch angle glue block.
Did you say 1 inch?
Okay, now what about the stringer?
Sorry,
thread?
I want to make sure I have it in the notes, right? Can I interrupt?
What did you say, Tara?
Can I interrupt? I'm sure I have it in the notes correctly. So I put attach with pocket screws and 4-inch glue block and 1-inch staple, but then I think I heard you just say 1-inch glue block. Is that correct?
What, so you had it's 4 inches long and then 1 inch by 1 inch. Yeah,
Thank you.
but you had it.
And 1-inch staples.
Mm-hmm.
Okay, all right, now how about the tread to the stringer?
Glue block, same.
Is there a pocket screw there? Is there a fastener down through the top? So the only thing that's holding it down is the connection to the stringer, is the connection to the next riser?
It's
We-
the
We finish nail down through the top of the tread into the stringer.
That's kind of what I thought.
mhm.
Okay, so if we use 2 finish nails,
Kind of
like
where the
that.
balusters would go.
2 1/4, 8 penny, something like that.
Sounds about right.
Okay. 2 1/4-inch finish nails.
And those are probably going to be 15, either 15 or 16 gauge. I don't know of anyone that would be hand driving, unless I'm wrong, hand driving 8 penny nails. They're going to
No.
be pneumatic and a 15 gauge.
Correct.
Well, you're looking at a guy that used to do that, but he used to.
And they're probably
When I had hair here with a little bit of grease on it, I used to rub them like that. Then I that
They're
takes a man to drive that without drilling, let me tell you. Okay,
I don't even know what an 8 penny nail is.
and we're gonna do 2.
They're probably 2 inch or 2.5 inch. I don't know if
2.5. Okay. 2.5-inch finish nails. 2 per end of tread. Okay. All right, I think, is there anything else that we need to deal with that? We already talked about how we're gonna fasten the miter.
Mhm.
We got all our glue blocks, we got everything. Okay, so now let's take a look at the drawings that Chase did.
You want me to share?
I got it.
You got it.
Okay, so this is what I'm showing right here is element 4 again. I don't know if it's big enough on your screens. Okay. So my first thought when I looked at this was we can't do a wall stringer here. And my reasoning was that the end of the tread and the end of the riser are basically going to sit on the bed of the testing machine. Okay, so the bed of the testing machine would be here. And then to get the outward load, we're gonna put a either an actuator from the bed up here, or we're gonna pull with a strap on the post in the outward direction. Okay, because this will be, maybe I can orient this.
Hey, Dave, while you're doing that, didn't Eric send a note about how this assembly was going to be mounted? That I thought after reading it, he wanted a wall stringer and he wanted our tread box to be mounted the way it would be mounted in a house. Did I misread that?
Well, I
Or is that
think
for
my
his?
impression was that he wanted the tread and riser to be mounted as it would be in a house. So, I mean, what's going to happen is, it's going to pull right out of the wall stringer because I don't know. Well, what do you guys think?
Well, I agree. I mean, that's going to be probably going to be the failure point. But I thought that was his point in his email, that he wanted to show that. Now, is he talking about the testing that he is doing, or this, or what
No,
we're
no,
working on now?
no, he's talking about this, but I think what he was concerned about was that the condition of this connection right here, these screws going into the tread and riser, that's what we test. Okay. And if
Okay.
this part of the stair fails, okay, then we've learned something. If we know if we test this with the wall stringer on, it's going to rip right out of the wall stringer, because in real life we've got this attached to a wall, we've got this attached to the floor. There's other treads and risers. Now,
So-
as far as this connection over here, we'll find this out in the full scale test. That's my
Okay.
I guess I was thinking of doing almost like doing this, not if we were doing this as a rudimentary test. If I was going to do this test in my garage, I would orient it like this and actually screw the wall stringer down to the floor, and then you could load the post. But I think I would also brace the top, the top of that tread as if it was kind of connected to a header almost. And that's what I was thinking of when we were saying tread box. And so if the tread is fastened to the tread would be fastened to that wall stringer with screws from the outside. And the load at the top of the post that's coming towards us, the tread would actually act as a hinge point. So the tread has the first support. And then the next screw is like so far down. Well, it's not that far down, but it's down low on the riser. I think the failure is going to be that screw pulling out and the other bottom screw splitting, allowing the whole thing to kind of rotate. I don't like if the riser is like wedged and glued and the tread is connected. I don't.
The load
Yeah,
is going to go from the bottom of the picture here to the top. So load is going to be applied to the inside of the post.
Okay, gotcha. Yep, that changes the.
So I'm thinking, because it's out and down. Okay.
Yeah.
So my thinking is that you're just going to rip this out of the wall stringer. But in listening to your explanation,
You're gonna end up pushing the bottom of the riser into the wall, and the tread is gonna want to pull out, but the tread is gonna have 3 screws going into the end, and it's gonna have a glued wedge. It would in reality, and it would be pocket screwed and glue blocked to the riser. So I think
You know,
that's what,
I agree with you. I just that it seems to me that what we need to understand is how strong is this? Not how strong is this? We need to isolate this.
so I think, I mean, we should, yeah, I'm not sure what the answer is. I think Eric would have an answer, but I think from a engineering analysis standpoint,
Uh,
that the post and the screws and the missing material is somewhat easy to analyze. And he, he could come up with he yeah, but then the other part of it, like the whole the riser wanting to push against and the tread wanting to pull out, how is that, what's the interaction of that with this whole thing?
So we have the data for top mounted posts. What we don't have the data is for notch posts. So MSU is going to get us the data for the notch posts. So I think to Dave's point, Dave's correct. That's what we need is the data for the strength of the notch post. We're not looking for MSU to see a failure of this on the stair front. We're looking to see how strong is the post. And then up in Massachusetts, they're going to test the whole assembly, and that's where we're going to see if the installed stair is weaker than the connection of the post to the stair tread, to the tread box. Is that correct, Dave?
Yeah, that's my understanding.
So we're actually going to be testing them. We're testing both elements in different locations at different tests.
Yeah, what would, if we get failure here, we're not going to understand how strong this connection is. And this is what I thought Eric was talking about. If this stringer blows out and the riser blows out and these screws pull out of the stair, okay, then we've learned something. And his point was that it's far easier to reinforce the stair and however we connect the post to the stair than it is to change anything in the guard system to make the guards stronger. In other words, what could you do? I mean, you could go with bigger posts. You could go with, I don't know what else you could do for this, to make the guard any stronger. So, but
you could
I
angle your
thought he was-
screws, Dave.
I'm sorry.
You could angle your screws.
Yeah, you could angle your screws. Yeah, yeah. You could put more blocking in here, but these are things that you would change to the construction of the stair. Not much. You're not really changing the guard elements, right?
Yeah, I think that we could probably use some clarification from Eric and Ruben on
Yeah.
because this is the overall thing is how specific are the sub elements. Like the testing at SGH is going to include balusters and the rail fittings as well, and those
Right.
are like the balusters themselves aren't really a tested sub element, but the
Yeah,
rail
they are.
fitting.
We've already tested them.
Okay,
We've already
Okay.
tested the baluster sub elements, and we've
Gotcha.
tested the rail connections.
hmm
And in each test, we've tested the and the top mount post connection. So each of those sub elements, once they're identified, okay, what their performance is like,
hmm
then we test the full scale. They can analyze how they perform as a unit
Yep.
based on where the failure points are or where the deformation is, in accordance with where the load is applied. Because when they do the full scale test, they'll apply the load here, then they'll go up here and they'll apply the load here, then they'll go up here and they'll apply the load here. So at different points.
Gotcha.
And
Gotcha.
and hopefully in different directions too.
So I think,
Because
I think I agree with you then about getting rid of the wall stringer on these and then Ruben can, you know, he can clamp or through bolt with angle iron or whatever to kind of hold the tread and riser as part firm.
Okay, all right, so we'll get concurrence. I think you're right. We need to get concurrence from Eric and Ruben on this. Now Ruben sent an email late last night, in response to it, I guess he's pretty busy, in response to an email that went out the end of last week, concerning the length of this unit. Now, we said we're gonna use, 12 inches, and the way it's drawn right now, we've got an extra inch for the nosing, an extra inch for the wall stringer. But Ruben was concerned that 12 inches was too short. And I'm not sure that I understood his email. He was thinking about, additional risers and treads to make this stay together. So there's some.
And Dave, we have Franklin on the call from MSU.
Oh, we do?
as well.
Oh.
Yeah, Franklin's on the call from MSU. So we've got some input. Could I share my screen just
Sure.
really quickly, if I can get that? See if I can figure out screen share. All right. This is just a real quick thing as we talk about testing, and Franklin, your machine may be much different, but this is an Instron testing machine. This one is in the AWI lab. But when we think about fixturing, whatever we fixture has to fit on a T-slot table, and the force needs to be applied basically in a vertical motion, either in tension or compression, one of the two. So whatever this tread box looks like then has to be fixtured to this table. And as you're applying the load, you can pull up in tension, and Franklin, please jump in and correct me if I'm wrong, but you could pull up in tension and basically have a greater amount of travel going in the upward direction. If you mount the tread box and apply a force down, depending on how much deflection you have, you may hit the bed of the testing machine before you create failure. And I think talking about the rigidity of the tread box, that's the consideration, is it has to be mounted up enough to deflect. It has to be mounted out away, and we're talking the length of the post at 30 or 36 inches, and then being able to calculate values based on that. But just as we think about it, this is the image that I have in my mind of how we have to fixture this. And Franklin, I mean, please weigh in on your thoughts here.
You're
I think-
muted, Franklin.
I think you're muted.
Oh,
Franklin, I think you're muted.
Okay, I got it. Can you hear me now?
Yes, great.
Okay.
Super.
I think the last time when they tested some posts and threads, they used 30-inch long
Yeah.
posts, and they had it real rigid on the thread box. They used angle iron to keep it rigid, and that's based on the length of our test machine. So we can test, and our stroke is 10 inches. So if you're getting, which is like 5 inches up in tension and 5 inches down in compression. So that's the stroke that we have on our test machine. And the 30-inch post came from that. That is kind of the middle point of our loading table. That's why they used 30 inches last time for the post in their testing.
Okay, so if I remember right, the tread box was probably about this size, right?
Carter, let's see, last time Carter did, they had the tread was, make sure. They had a thread that was 16 inches in length and 10 inches wide. That was the size of the thread that the coordinates that they use.
So now how, did you say the stroke on your machine is 10 inches?
Yeah, the actual stroke is 10 inches on the machine.
Okay, so your machine is much shorter than the machine that Ashley showed, is that correct?
Now we're gonna. I don't know what size stroke is on that one.
That Instron had up to 36 inches in the frame. So
No,
Yeah.
now we got a lot of movement. Now we can physically move our loading up and down, but the physical movement on our stroke is 10 inches.
I got you. Yeah, the
Yeah.
stroke of that was with the ball screws, we could get, I forget, but it was a substantial amount of travel.
Okay.
Yeah.
Well, I don't think we need more than 10 inches of stroke, but I mean, if this thing was up off the table, if the post was up off the table 12 inches, you've got no problem, right?
Oh no.
Okay, all right. And it could be up even 2 feet and you could still,
Yeah, you got a lot of distance in the vertical.
okay,
You can move the machine.
We got a
Right.
lot of Z axes.
Yeah.
Yes.
yeah, because the Z on yeah, there's the Z axis. So one of Ruben's concerns that he mentioned in an email last night, Franklin, was that he thought the tread would be susceptible to splitting at only 12 inches long. Should we make, I guess the question is, should we make the tread a little bit longer to make
Yeah.
sure that the tread and riser don't split?
Yeah, because on here they got 16 inches. I didn't see no splitting on the last time they tested on the threads. It's 16 inch long and 10 inch wide.
Okay, all right.
Thread. Mhm.
So since we don't have any, let's go with, let's try to be practical here. Let's consider that a standard tread is 36 inches. We're gonna cut it in half. We're gonna lose some material for the saw cut. So we're gonna go with like 17-inch long tread and riser. Does that make sense, guys? I'm throwing that out there.
Yeah, and it's also easily modifiable if it's too long at MSU. It just from a transportation standpoint, it's more, but it's easily modifiable to cut it down if they find it too long.
Well, it's not going to be easily modifiable if we put all these things together and send them down. Okay. Because my thought is that we have everything all pre-drilled, pre-cut, okay, the whole tread box is together, and then just for shipment's sake, we send the post separate from the tread box. They at MSU, all they have to do is fixture the tread box and then attach the post, or attach the post and fixture the whole thing. But my thought was that it would be much easier to fixture the thing, and it would be less awkward if the post was separate from the tread box. You don't have that big, thing moving around.
What was the decision? Were we using PL or PVA glue for the post to the tread riser connections? We are. So that would be something MSU would have to then apply also.
We're using, isn't that in the minutes? I thought we were using PL 3 times 3X PL premium,
Yep.
right?
Yep.
PL premium 3X.
Mhm.
So, I mean, we can supply that as well. And then, there'll be, constants through the whole process. Okay. And we'll have complete instructions on what to how to do it. And we can even send somebody down there and go through it, initially. So that can, there's time in the grant for all of that, okay? But I thought it would be far more efficient if we gave this stuff to MSU, built in our shops as accurately as we can. So that's the concept anyway. Okay.
Would it be, would it be better if the stair builder did that assembly?
Go ahead, Dylan.
Even if they're, would it be better if stair builders did that assembly, even if they're different? Potentially slightly different?
I
See, I
don't-
wouldn't think that MSU should, in an unsupervised fashion, be securing the post to the tread boxes. Whether if it's one of the stair guys going down there to physically do it and to oversee it, that's fine. But I don't
That can
think we
work.
were, even if we gave them instructions, I don't know if I
If
would
we had
to
somebody
Bill's, to
supervising-
Delon's point, I would feel more comfortable if somebody in the industry was overseeing that connection.
Yeah, I don't know that that's possible for every test for the duration of the testing. I mean, that's a lot of time. But what we did last time was we actually had one of the persons that was doing the testing come up and visit one of our shops where they were trained on how we do it. Okay. Now, ideally, we do have stair builders that are relatively close to we don't actually have a member in Alabama, but we have some that are relatively close. And I think we could go in there and do the training. So, this is pretty straightforward. This is a lot less complicated than what we were doing before with the SureType. Okay, there was a number of holes that had to be drilled. Everything was being done at MSU. Okay. Here, my thought was everything would be pre-assembled without as far as the post attachment, it would be done without the glue, disassembled. Okay. And then shipped down. And now all you have to do is put the glue and screw the post. How long does it take for that glue to set?
A day.
A day?
It'll be partially set way quicker, but, and if you make it wet, it sets up quicker, yeah.
Yeah.
It's
so
water
my idea
catalyzed.
of putting up, yeah, you'd have to have the whole thing assembled to put it into the fixture then. Because they're gonna have to be assembled ahead of time before they test it.
I am concerned about it being assembled right. I guess, that's all I'm saying,
I couldn't get that, Dylan.
I said, I am concerned that it does get assembled correctly.
Yeah,
That joint gets done correctly and
I can
as
go
faulty
down there
installation.
and camp
Yeah.
out in a tent or something.
You can
Hey.
come live. You can come live with me, Chase.
All right.
We'll
Well-
go over there.
Hey, what?
Wintertime, right?
I mean,
I
I
don't,
can spend time
Da-da-da-da-da-da.
I'm not a stair builder. I'm not a stair builder, but I can spend time over there, and I understand glue spread and stuff like that. But I would have to be trained. And that,
Tom can train you.
yeah, right, yeah.
Tom's been trying that for years.
okay, all right. I think we've got this to a point where we need to move on here to something else. Is any other major issues here? Clearly, there's a few things we're gonna have to work out, but we're gonna need Eric and to confirm this, and we want to get everybody to agree on the length of the boards and what we've decided so far. So Okay, are we comfortable moving on to the next one?
Yes.
All right. Let's see. Um, all right, as far as this one goes,
You'll want to share your screen again, Dave.
oh, I'm sorry, I thought I was sharing. Okay, we've got this one. This goes on the face. And here's the plan of it. Okay, you can see all three views. I would imagine we're gonna attach the tread and the riser and the stringer all the same way here. I think I had no issues with any of the screw locations as we had decided the way they're shown here. These were in line 3/4 of an inch in. Anybody else got any concerns with this?
So we were gonna do, for just to reiterate, we're gonna do pocket screws and glue block from the tread to the riser. And
Yep.
we're gonna do two 15 gauge 2.5 inch long nails down into the stringer from the tread. And
Right.
and we're gonna glue block that as well.
Yes.
And then there's gonna be, so is it a 1x1 glue block like I'm showing between the riser and stringer?
Yeah, we said
Yes.
we were gonna use a square one there, but we were
Okay.
gonna use triangular ones under
Um,
the stringer, against the stringer and the riser and tread connections.
yeah. So when I was in the picture, in the drawing in the meeting minutes, there's a 2x4 piece of blocking behind that. And I think I remember in the meeting that we said that the screws were going to be in shear because they're loaded from the side, and that the block was kind of incidental, but I don't know if I'm remembering correctly.
What you saw in that drawing was the end of the rake wall.
Hmm.
It wasn't blocking. It was
So
just
we're
showing the rake wall termination at the floor.
mhm.
Okay. What was in Dealin's drawing? Is that right, Dealin?
Correct.
Yeah, you are correct. We said we were gonna do no blocking. Here, it's just as you've drawn. What I would say is down here, this glue block is what we were just talking about, is gonna be triangular, not square.
Yep, those other ones. Yep, I got that.
All right.
Now the other thing I was thinking about as I was drawing it is like when there's a rake wall, that the end of the top part of that stringer ends up being braced from twisting.
Right.
And that may have, I think we did talk about that a little bit, how we could kind of mimic that in the testing. But it's not, I don't think it's going to have so much effect on element 5, but I think it would on element 4 because we have those screws, the screws going into the stringer, that bottom
Right.
screw.
Yeah, I've given
But
some
the-
thought to this, and I was looking at remembering the fixture that Franklin, or that MSU, I don't know if you actually did any of the actual testing, Franklin, but that fixture was built out of angle iron. And so I was trying to envision how all of this would be clamped down. And then I thought, golly, you could just make like a steel box that would fit inside of this tread box. And be able to maybe make another box that then you slip the tread box over the box that's clamped to the testing machine surface, table surface. And then there's another box that goes over that that holds the stringer and the riser and the tread down. And that could be, fastened to the table. So I think there's ways that this could be, I guess that's what I'm getting at. There's probably a dozen different ways this could be fixtured. We'll probably leave that up to MSU, but
Yeah.
you're right. That stringer needs to be rigid, the riser needs to be rigid, and the tread needs to be rigid, so that what we're testing is the screws and the post, and what they are actually connected to in the tread box.
The blocks between the tread and the riser, the triangular blocks, how many are we gonna put in that 17-inch spread? 1, 2, what's normal? I mean, you put, how long should the block be and how often?
What I've seen when people do this, the different shops that we've looked at, they're depending on the width of the stair, there's 3 or 4. If it's a really wide stair, there's a lot more. So we're basically a half width stair. I would say 2 glue blocks.
Everybody agree on that?
I agree.
And where are they gonna be placed?
Well, there'll be one under the tread up against the stringer in this location. And then there'll be 2 along at this joint between tread and riser.
It'd be equidistant. Typically, they'd be
Equidistant, yeah.
How long are they? How long are they?
4 inches.
approximately 4 inches.
Okay, you're gonna standardize that length. Okay,
We
all right.
did, yeah.
okay. No matter where they go, they're gonna be standardized. I got you. Okay.
Okay, anything else with this that you guys see? All right. So as far as fixturing, it seems like the fixture could be designed so that it would work for both 3 and 4.
Hey, Dave,
Yes,
in diagram 1, there's typically also a glue block that runs between the cut stringer and the tread underneath.
yeah, we said
Right.
that right here.
But I don't, yeah, but okay, so it's not drawn there then.
Oh,
Okay.
I'm sorry. Here. Here.
Correct,
here's the cut string.
but it's not shown in the drawing.
No,
It-
no, we need to add that.
Well, it is shown, but as a 1x1 instead of a triangular one.
No.
No,
but
no,
under the
because that,
stringer.
It's not shown in the side view, but it's shown in the front view. So go down, see that stringer tread, right?
oh, yes, you're right. Yes, you're right. I see it now.
I'll update these
Oh,
to show.
stringer. Okay, yeah.
I see.
Okay. All right,
I see, said the blind man.
yeah. All right, where it's not shown is under the, here at the riser. I was thinking that was the, so we need to add it here. In this location. Right, Chase?
Okay.
Okay.
The way that I showed them was just the ends. You know what I mean? Like I didn't show a separate line in each of the views to show the side view of the glue block. But I can do that. I just thought it might be too many lines. I do that though.
Oh, here it is. Here it is right here. I got you. Okay, you've got it everywhere. Okay, you do have it. My bad. Okay. We good with these?
Yes.
All right.
I'm gonna have to leave, guys, and so I'll catch up on the next meeting, hopefully. All right,
Thank you, Louis.
thank you.
Safe travels.
All right. We're halfway through the meeting. And now we're going to go back to the minutes here. Screen. Minutes. Okay. Chase, you haven't drawn the elements 1 and 2 yet. But it's your intent to draw them, right?
I do have I have it in the AutoCAD. It's just not very clean.
Do you want to
But
share your screen?
I could share my screen, I think.
Okay, I will stop sharing. I guess I am stop sharing.
Okay, let's see. Get too much stuff up here. So element 1, right, is this
Yep.
is this gooseneck. Did we decide on a rail profile?
It's 60-10. What you got there, it looks like.
Yep, so I got 60-10, and this is the right post, I think.
Yeah.
3-inch base, 40-10.
Yeah, 40-10.
So we're gonna do this pitch is for the 7.5 rise 10-inch run.
Exactly.
I'm not sure what this dimension is, what the
Well, that's gonna be
horizontal.
a turnout, not a cap.
Yep. But it'll
But it
So-
kind of look like that, yeah.
yeah, so I have the plan view. I can do the plan, but is that, so we said that that's gonna be a factory joint?
Yes. It's gonna be a clamp nail. And then, so Franklin, we need some input from you, okay? So what we're trying to test here is we're gonna put the load square on that basically about the top of that pin and the center of that pin where he has that pin drawn, the blue pin going into the pink cap. The load is going to go right there. And what we need to know is how much do you need to fixture in your jig? Do you need us to add? You can see where the cursor is. There's a straight piece of rail that's been added to the easing. Do you need that? Do you need us to add that piece of rail? You're muted again, Franklin. Sorry.
Okay, yeah, I'm trying to see, I guess the distance, is it like a spinning motion, torsion? You
This
trying
is
to
a-
get?
Yeah, we want to put the load on the cap. Can you put your cursor right where we're going to put the load,
So we're gonna put the
Yes.
load,
Chase? No, right there. Yeah, we're going to load that. So what you need to fixture is the post.
Uh-huh,
Okay, that needs to be rigid. but then the rail has to be clamped in. And so my question is, do you need us to add that straight piece of rail on after the curved piece to have enough to clamp to?
Yeah, that'll give us more possibilities. But I'm trying to see, what kind of force is that we are plowing right there? Is it a twisting motion or?
No, just a load going either into or directly out of the page.
Oh, okay, okay.
So the
you-
clamp, the top of this post will be clamped so that it's stiff. And then there will be a clamp here, however
Okay,
you want to do it.
okay. So
And
it's
then,
like, okay, so,
so we're really testing these two joints along with the glued pin and the screw.
I see. So almost like a shearing motion you getting at?
Right.
Well, I think it's going to apply. Yeah, it's going to end up with a bending on these two joints.
Okay. But
And a part of what makes that bending moment is going to be how far down that newel post is actually clamped.
yeah,
And how far up the rail is clamped too. So
Correct.
I'm not really sure that might be.
This is the one that I have struggled with what we are actually testing for in terms of the strength.
yeah.
Mhm.
Yeah, because there's so many variables here. I don't know.
Yeah, that could be depending on where we apply the load at on that one. And I don't know exactly.
So we might need some input from maybe Eric or someone, or I don't know.
Yeah. Now we can easily clamp it. There's no problem with the clamping and it as compared to where we put the actuator. That'd be no problem there.
I kind of think that if we're gonna get a real look at this, that we need to clamp that as low as possible on the post, but no lower than where the post is gonna be fixed to the tread. So if you can zoom out and yeah, move that clamp down so that's even with the tread in the picture. Yeah, there you go, right in there somewhere. I think that's the reality of it all, okay? Because, you're gonna have a lot more flex. If you clamp it too close to the top, then you're not really gonna understand what's going on.
So this is kind of that same question of how far are we breaking down these sub-assemblies? Like we have a test for the stiffness of the post, and I think what Eric would want is he wants to understand this joint connection, including this joint, but not including this joint.
Right.
And also not including the stiffness of the post. I think.
And how far from the post moving up the rail, you've got the up easing, but your first baluster is going to hit probably somewhere where that clamp is, but that first baluster there is going to hit somewhere in there, which factors into the stiffness of that joint and resist the bending moment.
All right, so this is another question for Eric. And if you could let's get a screenshot of what you've got right there, okay? And then I want you to move that clamp down to where you had it before and let us get another screenshot.
Is Tara on? Is she doing that? I can do the screen grabs and send them to the group.
I'm doing it.
Okay.
Okay, she's done. Let us know when we can move the clamp,
You can move it. I already have the first one.
okay?
So
Yeah, right
this would
there.
be the top.
So, yeah, okay. We can identify those squares as the clamps. Okay,
Are you ready for me to grab that one then? It's ready.
yeah, go ahead.
Yeah, I can clean these up too to, so.
Okay, thanks.
All right, so we're good with this. Let's go to the goosenecks.
So I started to lay it out and I was kind of curious about a dimension, how far off of the post. Typically I start with 1.5 inches for like the bottom of the, not 4.5.
Isn't it standard, the back of the rail drop,
Anybody, is
3
anybody?
5/8 to the center?
They can measure?
Isn't it 2 5/8 standard from the back of the rail drop, center of the hole?
Back of the rail drop, center of the hole, 2
I
5/8.
think.
Yeah, that's pretty close.
Would be right there.
And then
I'm gonna double check that standard. I came up with a whole list of questions that I've sent to everybody. As far as the type of glue they use and a couple of different dimensions and all kinds of stuff. So, Crown Heritage has responded and I'm waiting for the responses from the others.
So I can call some, because I'm sure they have drawings of these, because I would like to have a plan drawing of that turnout too. I might have one in the database, but I don't know if it's accurate to what we're
I've got some of those drawings.
60/10.
Yeah. That's where
Still
I'm
talking
getting
about
at
that dimension?
2 5/8. It would be home stair parts. I don't know. I think they're standard amongst everybody.
What
There's
do
no
you say,
doubt just-
Paul?
So you're still talking about from the center of the post to the back of the drop,
Yeah,
Yeah,
the inside of the rail?
yeah.
We do 2 5/8
Okay,
Yeah.
that's what.
from the
Keelan
center of
said.
the post to the inside of the rail,
Yeah.
underside of the rail.
Okay,
So you don't need a booger baluster.
right.
booger baluster. I've been looking for that term, Paul, for so long. Thank you. So
Good name.
this one is gonna be 1 riser gooseneck and then 2 riser gooseneck. It would take me a little while to, I don't know if you guys want to watch me draft them up.
Absolutely.
You want?
Well,
Do you-
I love it. I can learn stuff here.
let's just
Um,
zoom in on that. Just zoom in on it. Well, we need to, yeah,
There's my booger baluster, Paul.
okay. Where are we gonna apply the load? Yeah, zoom in on that one, the 2 riser. It's not disconnected. Be
A
easier
little
to
more
see.
representative,
Yeah,
but still needs some dimensional tweaking. I think the load was going to be applied right at the miter.
Mm.
Really be an outward load.
All right, so Franklin, just so you understand, what we're gonna send you, what you see in this picture is what we call the cap that sits on the top of the post. We call that a quarter turn cap. That portion, this whole thing is called a gooseneck. The portion that's level that sits on top of the post is called a quarter turn cap. What we're going to send you so that it's easier to fixture is what's called a tandem cap, and the outlets are at 180 degrees like that up there.
I think
Okay?
I think we decided we were gonna do a straight rail instead of a tandem cap because it would be easier to
No,
fixture.
we switched back to the tandem cap because the tandem cap will be a factory joint with clamp nails at the miter.
Gotcha.
Okay, so
You can buy a seven.
and the reason we did that, was because what is it, 7099, like you're showing there, the straight section is so short that we didn't think there was enough to clamp. And even though they have the cap to deal with on the tandem cap, that is basically, I think, 11 inches long, something like that, from the tip of the miter to the end of the, the full length of the tandem cap is about 11 inches is what I've gotten from one of the vendors. So there we go. We're getting closer there.
This is taking a while.
But I thought we were going to apply the load not at the miter, but a little bit down further. But do you see any issues with fixturing that, Franklin?
Oh, no, I don't see any issues with them.
Okay, so we're going to apply the load somewhere. We'll have to get concurrence on that from you guys and from Eric. But just imagine using the stair. You're standing on the stair and you use you had to take a fall or something, and the load is going to be applied to the rail outward. It can also be inward, but we're dealing with out and down. So at some point along that curve point part, or at the miter, or on the straight part that goes into the miter, is where the load is going to be applied. So the idea is you'll need to fixture that tandem cap, the level portion in this picture, so that it's rigid, and then the load will be applied somewhere on those parts that are vertical or sloped.
Is it going to make a difference if you use a 90-degree up or a 60-degree up on that?
I'm not following you, Dylan.
The up easing, the
Mhm.
ramp, you call it, I think. They make those in 90. We usually use 90 degrees. So you don't have that booger baluster coming into play so much.
But
That was
Will it
gonna,
make a difference in the forces
I-
if you use a 90 or a 60?
I don't think the factory goosenecks come with a 90 though.
Oh, they don't. Okay.
No.
Okay.
So we'll have to, I made the balcony rail 38 inches tall to give us some more, and then I can move that gooseneck in to avoid the booger baluster, but the exact geometry will, like, I think in order to make I don't know, I'll have to play with it.
Play with some heights.
Yeah.
Yeah, the 90-degree up's a 5-inch radius. The
Yeah.
60-degree up's a 9 3/4 inch radius.
Oh, it's a 9 3/4 inch radius.
9 1/4, I think, to the bottom.
I thought it was 9.
Well, I know some of them are 3/4. Probably depends where you go. Who the manufacturer is, probably.
Yeah, we'll have to get that too. We need the radius.
HDI standard is 10, and I know off the top of my head if I'm doing a drawing with stock fittings, it's 9 inch. It's draw it with a 9 inch radius.
Yeah,
But
we usually use 9 3/4, but you know, we probably get sourced different. That's
or
interesting.
or we're both wrong, and it's 9.5.
Okay, so we're okay on this one? Yeah, you know what to draw for this.
Yep, I'll take my best stab at the 1 and 2 riser gooseneck and
Okay,
dimension
great.
that up. And
Super. Let's go on to, I'm gonna, if you can stop sharing. You haven't drawn the one in the center of the stair yet, right? That's the next one we want to discuss. So where we have a post in the middle of a cut stringer, in the middle of a flight with a cut stringer. So let me share my screen. Yeah. Okay. Basically, I would imagine that we're going to have something like what we see here. Okay. It's going to be a corner. Whoops, wrong picture. Something like we see here. It'll be a corner mount. Okay. And the stringer will continue on down because, you know, we've got treads down below here and we've got treads up above here. Wow. Are we going to do this any different? What we would do is this post would extend down further, and that was what I was saying before, or in prior meetings. So the post would come down into this area and drop below the next tread down.
Below the cove, so the cove dies into
Yeah.
that post.
Yeah, exactly. So and leave a little bit of room for, you know, a bevel on the post. So the post would probably come down an inch and 7/8 plus maybe another half of an inch, maybe another, say 2.5 inches, something like that. What do you think? So now we've got to build something that replicates that. Now the tread box is quite a bit larger, okay? Because I think we want all of this to be an integral. We want this much. We want to extend this line on down, okay? We want to add more stringer down below here, okay? And another tread or some portion of a tread, and the post would come down below that. So can we say that we would continue with the same kind of thing? We'd have this riser would be connected to this tread, and the tread would be connected in the same way to the stringer as we have already described.
This now becomes what, a 3-tread assembly?
2 tread, I'm thinking. 1 tread, 2 tread. Have
Okay.
another tread down here. And the stringer would have 2 cuts on it. So now we've got something that's probably close to 2 feet across. Will that fit in your machine, Franklin?
Franklin, I think you're muted there.
I have to verify it. It's pretty close to the distance in between our loading posts.
And that's also gonna shorten. I mean, now it's gonna be probably about 2 feet by 2 feet, okay?
Okay.
So now the post, if all you could fit was 30 inches before, you're gonna lose another 8 inches at least off of that 30.
Mhm.
Really going to depend on the geometry because the load is going to have to be perpendicular to the top of the post. Which is going to make it interesting thinking about this, depending on what post you use there. If you have to shorten the post to attach it to the stringer and tread combination, are you going to have enough? You're basically shortening the profile of the post completely. So if you get down to that 28, 24, 28 inches, you don't have a square block at the bottom of the post to notch in and attach, or you don't have the top of the post for the cap to fit on. One of the two. And
Yeah,
that's
we're not-
going to
we'll
be the
have-
same for the newels.
Yeah, the idea would be this portion of the post would be the same except longer down here, okay? The
Right.
top of the post, we would have to cut more off the top of the post. I don't think we're gonna have room if it's only 30 inches. Basically what they had set up before was, and that may not have been the full max, they might have just, but in any case, they had 30 inches from this surface up to where they applied the load, okay?
Right.
Now, what they did in that test was they just factored in a different lever arm and adjusted their data for the actual length of the post, which
Right.
might have been 36 inches, right?
Right. So we're not
So-
applying the force at the cap, you're applying it somewhere along the length of the post. It may be in the turned area or profiled area of the post.
Yeah, so
And the data is extrapolated from there.
yeah, and what they were testing then were basically square posts. They were not turned. Okay, so I think we'll be okay. I guess that's another question for the engineers, but I would prefer to use the same turn post here. So with that, Chase, do you have enough information to be able to draw this up? What we're talking about now?
Yes, I was kind of drawing it out a little bit as we were going.
Okay, all right, so now what other fasteners, are there any other fasteners than what we see here and what we've discussed? Now, to my thinking, it would make sense that if this is going to extend down into the next tread, that we at least put another screw right here, okay, into that next tread.
I would bet that there's gonna be 4, so like this thing is gonna be notched like it is
Just
in
like it
the-
is here.
but it's not a corner post,
It
right?
is
So
a
it's,
corner post.
but it's half, it's applied to the face.
No, it's a corner post in the middle of the stair.
Of an L-shaped stair or a
Middle of the
straight stair?
flight. Huh?
Of a straight stair.
Correct.
Of a straight stair.
Okay. So it's a corner post, but then once it extends past that second tread, it's then notched
Half.
as a half.
Yes. Yes.
Okay, yes.
Excuse my ignorance. Is this element 3 we're discussing?
This would be element 6
6. Thank you.
or 5. What is it?
Think
What do we do?
6. You got it.
6, yeah. Because we did 4 and 5. Yeah, this is 6.
thank you.
So I think of this as instead of like a corner post, it's an intermediate post.
Yes, it's an intermediate post, but it's identical in this area that we're seeing right here. It's identical. We don't want to change anything here. We've discussed all these fasteners,
Okay.
glue blocks, everything, the tread connection, the stringer, all of that would remain the same as what I'm proposing, okay?
Mhm.
And then where this drops below the next tread, we put one more screw into that tread right here.
I'd agree. That makes sense, Dave.
Or 2 screws.
Well, we could put another screw over here into the stringer. You're only going to fit one in the tread.
Okay.
Do you want another screw into the stringer?
I don't know how much
I
it's going to add. Because you're in the miter of the riser to stringer at that point, no?
Well, we've got screws this way going into the riser, okay? And we've got screws going into the stringer here. Okay, and we've got another screw into the tread up here. And so this is going to come down below here. What did we say? How far down below did we say?
I thought you had said 2.5.
2.5 inches down, okay? And we'll have one more screw here into the tread. Do we need any other fastening for this post? Okay, so the benefit of another screw here is that in the field, this screw, okay, if we get it down below the tread, it's going to go into the wall. Possibly. You know, we've got the top of the wall coming through here,
Mm-hmm.
okay?
Maybe
So,
we can't count on that though.
yeah, we can't count on it, exactly. So are we good with that one more fastener? And we're going to use the exact same screw that we used into the tread up here. And we're going to drill it the same way, same bung.
Mhm.
So my only question here is shown, and part of this is a CAD thing, but this is shown with like a cap head screw, which is a load bearing head. Are people using cap head screws, or are they using standard tapered screws? Because that's going to make a difference in load values. Because that tapered head acts like a wedge in splitting.
I think they're
think
showing a
this is a
bung
tapered.
hole with a regular
Yeah. With the
countersink.
Okay, the countersink
ca-
with a tapered head.
Yeah.
so yeah. I think I'm not sure the wood screws, what I call wood screws, I guess, have a tapered head. They don't have a cap head.
Yeah.
And that is what I'm trying to show in the drawing, but we're also showing the bung. So it's going in.
Well, that's a good point, Ashley. Maybe that's a fallback for us
Yeah.
if we get pulled through.
Mm-hmm.
Well, see, that was the thing when we did cabinets and cabinet backs, using the cap head so you had a surface bearing head made a substantial difference. It wasn't the screw diameter as much as it was the surface bearing head versus the tapered head of the screw.
Mm-hmm.
Caused the issues.
What do you
Mhm.
think, guys? Do we want to start with cap heads?
My only concern is I don't know if anybody uses them.
We do some, but I think industry standard would be these tapered.
Yeah.
instead of a cap.
I think
head,
you're gonna easily
which-
get your 500 pounds if it's glued properly.
I mean, you could use a flat head instead of a cap head.
The cabinet head, we call them. We use some of those. What's the proper term for those actually?
It's a cap head or surface bearing head, but you know, a lot of people do call them cabinet screws. But the thing about it is, though, if the industry is not using them or not using them yet, I wouldn't personally, I wouldn't say start there. But Dylan, you make a great point. Is the screw a fastener or is the screw a clamping device for the glue? You know, that's what we'll find out in the test, is that if the glue joint fails, well, you know, the screw was actually a clamping device for the glue to set. So,
Okay. All right, we're gonna stick with the
wood
with
screw.
the countersunk screw. All right. With the bevel head.
Could we, let's say we get a bunch of too much failure. Could then the cabinet, I'm calling cabinet screws, could those then be used, tried, tested? Or is that too much money, too much retest? How's that work?
I think to change from a bevel to a flathead is just a matter of
New box of screws.
a new box of screws, you know, changing your
Well,
inventory out.
You've already blown some of the, by testing the tapered ones, you've already blown some of the allowances, I guess. But I believe most people use tapered heads. But
Yeah, I agree.
That's a good,
we like the cabinet screws, but we still use some tapered too.
that's a good thought though, Delon, is like, say the very first sub-element test we do is element 4 or this one or one of these, and we only have one of the but then we're setting up and resetting up the testing machine, I guess. But if we tested element 4 or this one first and it immediately, you know, failed, are all the other ones already assembled and on site, or do we have the opportunity to kind of reconvene and say, you know what, let's do, I don't know.
You could even back the screws out and put different screws in, but by then you've cut that wood grain. That
Yeah.
second screw's not gonna hold as much as the first one will.
I think if these are screwed and glued the way these are designed, the post is going to snap before the screw fails
I agree.
or this pull out.
I agree 100%.
Okay, we're good with this? All right, so the question here is, we need the drawing of this, and we need some overall dimensions, okay? So that we can understand the fixturing of this.
Mhm.
Franklin, I have a question for you on your testing machine. I don't know how to put it. Does the load, do you have the ability to apply the load at the corner of a table or off center of the width of the table? Or does it have to be on the center line of the table?
But Axwood is designed for the center line.
Okay.
Center of the table.
Okay, all right, so then this would be placed in a equilateral position and parallel with the center of the table. Okay, what I was thinking was you might gain some space if you tip this thing on an angle on the table, but then, you know, the post is not going to be, it would be over here and not where you can grab it to load. Okay, all right. All right, let's we've got the details for this. Chase, you have everything you need to be able to draw this?
Yes, all set this for element 6.
Okay,
I
let's go
I
to-
took notes down. I might call Mr. Wishnoff or Delon for some final dimensions, or I'll send it to the.
okay. Yeah, scoop. All right, let's go to
Lose my number.
what was 7? Okay, opening landing post in the corner at the top of a stair.
Hmm.
We said that we are going to leave 2 1/4 by 2 1/4. So we don't have any drawings of this, and I don't know if you can use anything you've got there in AutoCAD, Chase, to kind of synthesize this on the fly. But basically we're looking at the top
Yeah.
of a stair, this 2 1/4 by 2 1/4 remaining portion of the post is going to go up against the framing of the floor, and then we will have the landing tread abutting it on both sides. This is under the premise that you're going to cut the stair stringer and the riser such that it butts this 2 1/4 by 2 1/4 section remaining that's tucked in between the butt joint of the stringer and the riser and the framing. And then later on, the landing tread is put into place.
I can share my screen, Dave.
Okay, I'll stop sharing.
This one is just kind of rough.
Now, I don't know if people could understand what I was describing, but does that fit with what we've talked about? So you need to offset 2 1/4 by 2 1/4.
Yeah. I thought we had a picture. Maybe I didn't have that one yet.
Well, we didn't have a picture of this one. All we have is the note at the bottom.
Okay. So this is the line of the nosing,
Yeah,
and then I'm going 1 1/4,
then
3/4, 1/2 inch for drywall. So then this becomes the rough framing. Yellow is rough framing. We'll say that these layers are plaster. These ones are the riser. We'll make those, maybe we'll make them dashed. D-line was using dashed, I like that. So we're gonna leave. Was it this whole thing? Because we're going back to framing.
well,
Or-
we said we were gonna make it 2 1/4 because there's
Trim space.
and there's there could be joist hanger there, or
Yeah. So this is kind of the lower notch in the newel, and then
Yes.
up above it remains full.
yeah.
And then I think that, so how can I'm not as good with the hatch as Delon is. He'll have to show me that one. So I think we have
leave a lot of things the same from what it looks like. Pretty cool.
I think we'll have a screw, like both of our screw, or all, we'll have probably 2 screws going each way. I don't know if I don't know if they're 2 1/4 is enough to have 2 side-by-side screws. You know what I mean? So let's say. And these are gonna have to be longer screws or we're gonna have to countersink them more. Right? I mean, if we're sticking with 3-inch screws, they don't make it. These were 3s. Where are we here? We're over here. I guess we get into the framing 3/4. Then if we countersink it another 1/4 inch deep, we could get 1 inch into the framing. And we put
I don't think that's anywhere near enough.
so 4-inch screws.
Well, 3.5 anyway. Well, what are people doing? That's what we need to understand.
I've done these and I have 4-inch screws in my kit. We don't even have 3.5-inch screws at the shop. We order them as it goes 1.5, 2-inch, 2.5, 3-inch, and then it goes 4-inch, 5-inch, 6-inch.
Or countersink it deeper,
Yep.
get less meat, but there's a point where the extra meat becomes a waste, I guess.
Isn't that screw gonna have to be a little bit? Can you actually get that in there with the riser and the stringer in the way?
No, because you remember we said we're gonna put the fascia and nosing goes in after.
Well, you're at the top of the stairs, so you've got the stringer is already there.
No, oh,
We cut
Oh.
the stringer out.
I think this is, I
Yeah,
think,
but it's there. It's there, so you're gonna slide the post down in there.
And then angle the screws.
Probably.
yep,
You've got to, that head can't be beyond the face of the stringer, or that.
you're at the top of the stair. Hmm.
You have to assume that the riser and the stringer are already there. So you need to,
Fine.
there you go. Now you can get it in.
I only got to move it a 1/4 inch over.
Yeah,
Well, but then the drill's gonna get in the way. So
yeah, you gotta angle it.
we got to angle it, but I think that we decided we can't. That's gonna be difficult to replicate, or it's gonna be difficult. Well, look at that glare, huh? It's that time of
So
day.
you can go back to the 3/4 inch standard that we had before.
Okay.
Well, then what is
That's about what we got, no?
you're talking about in-wall blocking and framing that we're going into there.
Yep.
Yeah.
So that's the other thing that has to be determined is what does that look like? Are we talking about, floor joist? We're talking blocking. What is that going to look like?
I think we're gonna assume that it is something solid. Okay, so we could use 1.5 inch framing because it's not always doubled.
You're going to have a rail secured both directions here too, right? So,
No, only one
Oh.
direction. This is an opening cap, opening newel.
oh, this is opening, okay.
We want to test the most stringent. So Which one is the riser and which one is the stringer?
Well, I was thinking about this as I was thinking about it in a corner of a floor opening. So they're both they can be both be whatever. It's the same offsets for fascia, nosing, riser, stringer. Well, I guess
No,
it's
no,
not.
no, the stringer is 1 inch. That's why I was asking.
We can make it either.
Well, let's
So
identify it. Let's draw it and identify it.
okay,
That's
let's
gonna make a
say
difference which way we're gonna apply the load. That's why I need to know that.
it's this one. So all this stuff,
Is that 1 inch?
it's about to be.
Okay. There we go. Okay. Oh, you're making me so happy.
Huh.
No, could there be a scenario where there's an opening cap at a corner like that?
I don't think
An adjacent balustrade?
You got a balustrade coming back along the stringer, yeah, or fascia. So the rail is where his cursor is right now.
Right.
so. The rail's coming up, and I guess there could be like
That's the top of the stair.
there could be a wall right here too. I guess.
I see. I was
It
just
would be-
trying to imagine a scenario where you would not have to have a rail on that level. There, yeah.
No, that's
Because we all know what
that's
corners
the
do.
top of the stair.
Yeah.
Put that in there, top riser. Top riser. Okay, there we go. And you could make that stringer or fascia.
Well, it's got to be. It's 3/4, so it's fascia, right?
No, that's over there is,
1 inch.
no, that's the riser. You're on the riser now. That's not fascia, that's riser, top riser of stair.
Oh, okay. I was okay.
The other side is gonna be the stringer, the side of the stair, or the fascia.
This is how I'm visualizing it. This is the top nose and riser of the stair. This is the stringer. We've got the treads coming up this way, and then you have the rail is coming up, and then you have the balcony on this side. So that's where we're getting this.
No,
No,
you've got, no,
Where's that, where's that
No, this
screw
is
going
at the-
into though?
no, this is just it's only one rail. It's only one rail going into this post.
okay. So
The rail
This
is over
side.
the stringer. There we go. That's the top riser right there. Okay, the tread, now draw in the tread, 10 inches out from that nosing.
there we go.
There we go. Okay,
So I got you. So there's the nosing right here,
yes,
and
yes,
but so this is landing nosing that's projecting in. It's not
Right.
the open.
right, exactly.
So this is a wall stringer.
Yeah,
Okay. I was confused.
I was confused with Chase, I think, so.
I was
Made
picturing
more
something
sense.
else.
Yeah,
so this is the weaker of the posts. You know, it's only got one rail going into it. There's nothing else. And that's what we're trying to test. We're not concerned with any post has got two rails going into it. Doesn't even have to attach to the floor.
So this is level. This is level rail.
Yeah,
Okay.
no, it's me, yeah.
I'm gonna try and I have that 3D model. It just needs a few tweaks, but I think that I can represent all of these situations in that model fairly easily. So
Chase, can I share my screen for just a second with an
Sure.
image just to be sure we're on the same?
Oh, Send me a
Oh,
screenshot, please. Sorry.
I'll send it to you, Tara. You can share.
Thank you.
What we are looking at, let's see if it shares. All right. What we're looking at is this condition. I just was Googling for images, but
Yeah,
that's what we're looking at is this condition, correct?
correct.
Okay,
Mhm.
all right.
I think Chase and I were thinking 90-degree off.
Yeah,
Yeah,
I just wanted to be sure my visualization was correct on this too, so.
Yeah, that's it. That's
Okay.
it.
We're all there.
we got there. Huh?
Okay, so we got two screws going both directions, correct?
Mhm.
And where are they located? Um. Since the landing tread's going in after, let's put one in the center of the landing tread vertically. Okay,
Mhm.
in both directions. And then the other one, let's put up, what did we say, an inch and 3/4 from the bottom? Because that's what we can fit a drill into.
Yeah, 1.75 between
Okay.
it or 2 inches. So similar screw configuration as the other ones in height, right? We're gonna
Oh, the
try and
landing tread's not in there, so we can't screw to it. It's gotta be lower. It's gotta be lower.
yep. So it's gotta be
Gotta go into the
probably.
frame.
So we're probably gonna do around the same 1.75 inches down
Well,
from the subfloor or something, which is gonna put those screws pretty close together.
You could tuck it up pretty close with the simple extension bits.
Well, we're thinking about what we're going into. So, like if this is the top of treads, oh, this stupid thing's in my way. So that's 7.5 rise.
but now the floor, the back of the landing tread's only 3/4 thick. So the subfloor is gonna be down 3/4. There we go, okay.
So this
And
is
then-
really like the top of the subfloor.
Yeah, figure 3/4 of an inch of subfloor. Just for the heck of it.
Yeah.
This is like
Okay,
the
now
thickness of
that's
the
the top
nose.
of the framing. Why don't you draw in a 2x10 there? Behind the. Inch and a half by 9.25.
So that's a 3-inch post.
Thank you. I was just gonna ask for that. You make me so happy.
Oh, I lost my line though. All right. So this is our newel post. But it's really gonna be a 1/2 inch over. Yeah, is that, well, 1/4 inch over.
So looking at this and also kind of looking at time on this meeting, I think I have to spend a little bit of time thinking about how to jig and fixture this assembly, but also which direction in this condition is the load applied? Away from the stair opening or toward the stair opening, which will make a difference in how it's fixtured.
It's gonna be as the user stands on the floor and pushes out on the guard. So in this case, it's gonna be from the floor and yes,
Away. Okay.
as far as the fixturing, I think we just build a frame of 2x10s. And
Yeah, I mean, you've got an inside, essentially an inside corner condition where this is going
Yeah.
to be.
yeah, we just build everything up to it, you know.
All right. So is this element 7? Was this our last
Yeah,
one?
that's your
Um,
last one.
So I can clean these up, put lots of dimensions on, put it into a PDF and send it out. And I'll send the CAD as well in case anyone wants to play.
That would be great.
And maybe maybe if there's time before next week's meeting, I'll try and make this include a few more scenarios so that people can visualize.
I'd really like to get these out to Ruben and Eric before the next meeting.
The
Okay.
drawings, the 2D dimension drawing.
Yeah.
Yep.
Because you're so close to having it all done.
Yes. So
we could get
the
that
3D
wrapped up
is
real quick, and then we'll get that out to Eric and Franklin and Ruben, and we'll get some input on, you know, the fixturing and the load direction and the length of the pieces, and get all that finalized. Or at least get some additional input before our next meeting.
yes. I will do my best to make that happen. I would say I think I could do it for tomorrow around noon.
Okay,
Um
I'll give you till 5 p.m.
End of business?
Well, no, before that's before Scotch.
Before Scotch. Gotcha. I was up I like to work late at night sometimes too, so you might see it at 1 a.m.
Well, you and I were on at what, 6 to 7 last night, something like that. And
Something like that.
then I
Yeah.
was answering Ruben's 10:45 email still at midnight. So yeah, I'm in the same game. I think all of us are. I know Tara is. Oh,
What
Yeah.
are action items for the next meeting, and when do we want to have the next meeting?
okay, can we do 1 week from today?
Yes. 9 a.m. on November 1st.